in with like.
We have yours every time.
Thank you.
You make Roya carry all the food and you're just like walking in. Drinks.
That's you, right?
Where they got you something?
Thank you.
Check cake. Check.
Ooh.
She said you're ugly, you're fat. I'm fat.
Do you accept change or are you annoyed by change?
Calculation. Thank you.
Oh, of course not.
What kinds are they?
They're all spicy tuna.
Ariel, you have
Thank you.
Thanks for offering.
You should need to fail tomorrow.
Oh, you know.
Don't you have to pick up your
Made it. Where's the water filter? Mr. Ferrer, where's your water filter?
Over there, just make sure the lever. It should be the small stream of water, not the big stream of water.
Ariel, don't you have to pick up your brother or something?
That's really
Griffin, I'd rather actually her be here.
Yeah, because I get it, guys. You know what? I don't like you either. So why not?
We're agreed. No, you don't know me. I'll make it really harsh right now.
You know, I was seeing this quiz once. Like, one of the, like, they said that what would I rather have? Would you have a chicken fillet roll or hamburger? I picked a hamburger. And they said I'm German.
Yeah, sure.
Yeah, well, if by harsh you mean deny him more chicken, yeah.
How about Arnold?
What am I missing?
I mean, I just don't know.
Oh, no. I'm French fried out.
Being really harsh to people that like we're all being harsh to each other, and he's like listening to people like, oh, if you're being harsh to everyone,
This guy's pretty mean to me. You know, okay, we were walking through like the same yeah, you little. I don't need
I push you. When was this?
No. You know, from that transition from e-building to,
I know.
you know.
Oh, you mean when I accidentally nudged you and didn't realize that it was you?
I didn't even know we just like walk like the same way and then like we look at each other and then I don't get off.
Okay, let's go ahead and get started then.
Is anyone else following this?
What happened?
No, because Armand's trying to tell me how I did something mean to him, because apparently I don't remember it, but I don't know what he's talking about. And he's not...
Which makes sense because you don't remember it.
No, but he's also not being very cohesive with his storytelling.
Cohesive or coherent?
Both.
Okay.
Roya is the most beautiful creature on earth.
Wow. Okay, let's take a look at number 1. Some of these are going to go really quickly. So number 1, if you look at the series appears to be geometric. If it's geometric, that means that we can figure out the first term, which is 2, and we can also figure out the common ratio. So the only difference between two consecutive terms is they're multiplied by some factor, and it appears as though the factor this time is 1/7. So yes, this series is geometric with a common ratio of 1/7. So next thing we got to remember is that a geometric series will converge only if the absolute value of the ratio is less than 1. So is the absolute value of 1/7 less than 1?
Yes.
Yeah.
Yes. Therefore it converges. Maybe I should write the series converges instead. And just as kind of oh, there's my computer. Thanks. I think this means I need to buy a new computer. I'll need to sell more rice balls for that. How many rice balls will it take to buy a computer?
1,562.
That's a $2,000 computer, $3,000 computer.
The cost to make each rice ball?
No, really, what's going on? This thing is hosed.
Does it record through this?
Yeah, it's recording. I hope. Yeah, it's recording. All right, so there's our conclusion. Series does converge. For non-existent bonus points, you could figure out the sum. So for non-existent bonus points, you can say that it converges to 2 over 1 minus 1/7, which is 14 over 6, I think. 14 over 6, which is 7/3. Okay. Again, for non-existent bonus points. For bit points. Bit points. Oh, I could ask that on the test, but it's not necessary. The way this question is phrased, it's not necessary.
Okay. So if it's like multiple choice, can you just like add that somewhere and just get like extra points?
I will absolutely give you non-existent bonus points for that. Bit points. 2. Find the values for which the series converges. So we just need to make sure that we have a geometric series. So let's write out the first few terms. The first term is when n equals 1, we have quantity 3x squared. When n equals 2, we have negative 3x to the 4th. Oh, sorry, that's when x equals 1. You know, you are correct. The third term would be 3x to the 6th minus 3x to the 8th. No, that should be 4. And that should be 6. I knew I'm not that screwy. Right, so that's my series, and just like the previous one, if this is geometric series, we should be able to isolate the first term. That's 1. And then the common ratio. Yeah, negative quantity 3x squared.
If we just looked at it and we said that the 3x squared was the ratio from this, would it matter because it is absolute value?
It doesn't matter because of the absolute value, but I need to show it correctly. Alright, so for this to be true, the absolute value of the ratio, again, needs to be less than 1 for convergence. So that means the absolute value of negative 3x squared needs to be less than 1. Now there are a few ways to solve this. Probably the first thing you should do is realize that you have the absolute value of a negative, so we don't need it. We don't need that negative. Also, we have quantity squared, so we don't need the absolute values. So actually, this is sufficient right here. Okay. From here, you can square root both sides. That tells you the absolute value of 3x should be less than 1. Or the absolute value of x needs to be less than 1/3. This is a center of 0, radius of 1/3. Remember, it's x minus center is less than radius. Okay, so center series converges for center minus radius is negative 1/3. Center plus radius is positive 1/3. Okay. Questions? We could also do this. I don't know if you're really interested in this, but you could also say series converges to, again, this is for imaginary points, first term over 1 minus 3x squared. So when we say converges, we mean it converges to this function. So between negative 1/3 and positive 1/3, the series will start to look like this function.
How did you get that? How did you get
Oh, that's first term over 1 minus ratio. Okay, what are we on? 3? Gosh, I'm already tired. All right, let's write out our series. The first term is 1. The second term is 3x plus 1. The third term is 3x plus 1 squared. Next term is 3x plus 1 cubed. We're not going to write the general term because we're actually not interested. Next, we need to recognize that this is geometric. So geometric, which means we could figure out the first term, which is 1, and then the ratio is 3x plus 1. Just like last time, the absolute value of the ratio needs to be less than 1. And it doesn't really matter how you solve this algebraically. I'm going to divide by 3. Or x plus 1/3 is less than 1/3. So compare that to x minus center is less than the ratio. That is ugly, ugly, ugly handwriting.
The center is also equal to a?
Yeah, center is a. So that means the center is negative 1/3 and the ratio is positive 1/3. So converges for x between, okay, negative 1/3 minus 1/3, negative 2/3. Negative 1/3 plus 1/3, 0. Yeah?
If instead it said this diverges in the beginning of the problem, would you make it greater than 1?
Yes. And just to remind you, this converges to first term over 1 minus the ratio.
Yeah.
Again, that's imaginary bonus points. Watch, when you get an imaginary bonus points, I'm going to put a bunch of eyes on your paper. Imaginary.
Those like brownie points.
Yeah, imaginary points.
That's why.
It's like your score will be 92 plus 5i. It's actually really funny.
What was it? Is that what it'll say on Jupiter? 92 plus 5i?
I don't know if I can put that on Jupiter yet. We have to see if Jupiter allows imaginary numbers. Four?
Because he solved for x.
We good?
Yeah.
Okay. For function that's represented by the series for which the... Okay, so let's write out our terms. I know that was very abortive of me. X plus 2, x plus 2 squared, x plus 2 cubed. And this question's different because they're not asking for an interval of convergence. They're saying, we know that this converges for some values of x. What does this converge to? So again, geometric series. The first term is 1. The ratio is x plus 2. So the series converges to the first term over 1 minus the ratio. Be a little bit careful about the algebra here. So that looks like negative 1 over x plus 2, x plus 1. Let me know if that's wrong, because and of course, for bonus points, you can figure out the interval of convergence. And I'll let you figure that out, but that looks like -3 to -1. Questions? Okay. Yeah, Daisy.
I'm just confused from when you get -1 over x plus 1 to the answer. How do you measure it?
From here to here? It doesn't follow. I just did the absolute value of the ratio is less than 1 really quickly in my head.
So you solve for that to get.
Mr. Ferry,
Yes.
In questions like 3, if you were finding the convergence for 4, could you do the absolute value of the ratio is less than 1 and greater than -1 and then solve it that way?
You could solve it that way, yes.
Yeah.
Yeah. Be careful with your algebra, that's all. I think for question 2, it's a little difficult because you have a square function. So be careful on that one too.
Yeah, I can do it that way.
Yeah. Okay, any other? I'll give you a minute, yeah. Here's the idea. On the number line, there's only a small set of numbers for which a lot of these will for which the series will converge. We saw famously that the series is only going to converge between -1 and 1, right? So if you can kind of imagine like a circle. That's not a circle. I'm making a mess. If you can kind of imagine a circle like that. Okay. What would the radius be for that circle? So that's the radius of convergence. Or another way, that's just a distance from the center to the end of the convergence. Okay? That's weird. It's like you're taking a 2-dimensional object and flattening it out into a 1-dimensional object. Yeah, that's very high concept, really. This is where we talk about flatland. But we won't talk about flatland.
Yeah.
Okay, I think we're on 5, right? Okay, so find the function represented. So 5 and 4 are kind of the same thing. Let's take a look at the series. We got 1. We have minus x plus 3 over 10.
Why x plus 3?
It's x minus 3. Plus x minus 3 over 10 squared minus x minus 3 over 10 cubed. In this question, we're not really interested in the series itself. We want to figure out the function to which the series converges. I'm just going to go ahead and do the entire thing. So if we suspect this is geometric, and we should, we should figure out the first term. It's 1. And we should figure out the common ratio. That's negative quantity of x minus 3 over 10. So that means that this series is going to converge to first term over 1 minus the ratio. Okay, this is 10 minus 3, so 7. 10 over 7 plus x. Let me know if I'm wrong, because I did that really quickly in my head. Sweet. All right, and this is bonus. Imaginary points. It only converges for absolute value of x minus 3 over 10 less than 1, which means the absolute value of x minus 3 is less than 10. So this converges for negative 7 to 13. Negative 7 to 13. So in between negative 7 to 13, the series will start to look like this function. Outside of negative 7 to 13, the series won't look like this function ever, no matter how many terms you add. Six. We want the first 4 non-zero terms of the Maclaurin expansion for sine quantity 2x. 6. So x times sine of 2x. So Maclaurin, that means that the center has to be 0. The center is 0, so that means we can use our memorized formulas, which is good. Let's see. Sine is an odd function, so x to the first power is x. Good. X minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial plus alternating term, or alternating factor, x to the 2n plus 1 over 2n plus 1. Yeah.
What happened to the 2x?
Nothing.
You just like put that into him.
We're going to put it in now.
Okay, gotcha.
Put it in now. That was pretty slick, right? It's like I planned it all along. Yeah, oh, I absolutely did. Absolutely, yeah.
On the answer sheet, it doesn't give the general term. Would you want that on the FRQ even if it doesn't ask for it?
If it doesn't ask for it, you don't have to put it.
Okay.
You do get bonus imaginary points. Bit points. I suppose I should add or factor this in. So 2x squared.
Please excuse the interruption. If Armand Gaviatan is on campus, please report to the main office immediately. Armand, please, your ride is waiting for you. Thank you.
Are you sure that was you? It didn't sound like your last name. Okay. 2 to the 5th, is that 32?
Yeah.
Yeah. Six.
It said someone was waiting for it. I don't know who it was though.
32 times 4 is 128. And again, like we were saying, not asking for the general term. We're just putting it in there anyways because, well, we want those imaginary points. I wanted those imaginary points.
Do you want us to expand that? Do you want us to expand?
In this case,
to
you
128?
kind of needed to expand that because the x and the 2 no longer have the same
We
exponent.
couldn't have just done like 2 to the thirds, 2 to the fourths.
You could have done that too. Okay. 7. Find the Taylor polynomial, order 3, at x equals pi thirds. So first of all,
X, is that like A?
yeah,
Okay.
okay. This is not a Maclaurin series. So that means we have to start from scratch.
How do you know it's not
Yeah, it says about x equals pi over 3. Or at x equals pi over 3. So that implies that the center is going to be pi over 3. So our center is pi over 3. And we're going to have to figure out a few things. We want order 3, so that means that the highest power needs to be 3. The highest power is the third power. So we'll need, at maximum, 3 derivatives. So the first one is f of pi over 3. That's cosine of x, evaluated at x equals pi over 3. That's 1/2. Next is the first derivative. That's negative sine x, evaluated at x equals pi over 3. That is negative root 3 over 2. F double prime. That's negative cosine, evaluated at x equals pi over 3, which equals negative 1/2. And lastly, the third derivative. Was it for you?
No, wrong.
Wrong Armand? Okay.
Yeah, they say governor.
Root 3 over 2. Okay.
It was the wrong one.
Earlier in the class, when I asked you about this, you said it was just the first 3 terms, even if it's not the 3 derivatives. The 0 is the first and the second. And it's also like that on the answer here. It only goes up to the second derivative.
Oh yeah, that answer is.
Oh, was a mistake.
Yeah. Just whenever you see order 3, that means the highest power has to be 3.
Okay.
All the other powers that are less than or equal to 3. Okay, so let's go ahead and construct this. I'm going to remind you of the formula for Taylor series. So the Taylor formula for a third order polynomial is f of x can be approximated by f of a plus f prime of a times x minus a plus f double prime of a divided by 2 factorial times x minus a squared plus f triple prime evaluated at a over 3 factorial times x minus a cubed. That's the general Taylor polynomial for a third order polynomial, or a third order approximation. So now you're just going to plug in your stuff. F of x, no, cosine x, can be approximated by, what was the first one? 1/2? 1/2 minus root 3 over 2 x minus pi thirds plus 1/2, no, minus 1/2 times 1/2, negative 1/2, no, plus, I'm making a butchery job of this, x minus pi thirds squared plus root 3 over 2 times 1 over 3 factorial times x minus a cubed, no, x minus pi thirds cubed. Everything has a factor of 1/2, so you're pretty justified in factoring out the 1/2. It's unnecessary to do so, however, just so you should know. That's 1 minus root 3 x minus pi thirds minus 1/2 x minus pi thirds squared plus root 3 over 6 x minus pi thirds cubed. Now the way it looks in the answer is kind of weird. They only gave you a second order polynomial and then they put dot dot dot. That dot 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 is supposed to take place of the third or of this fourth term here.
So you're saying that we should make the polynomial up to what order it says, and then we don't put any dots.
Yes.
Okay.
Yeah.
How many questions are going to be on the class?
I think we're at 9 and 2.
And it's 50-50?
50-50, yeah. Okay. How are we doing on time? What are we looking at?
No, plenty of time.
How long have you been recording? Not very long at all. 34 minutes. Okay, number 9. We want a Taylor polynomial of order 2 to approximate cosine of 0.2. So in other words, f of x equals cosine x and we want to know f of 2, which is cosine, no, f of 0.2 equals cosine of 0.2, which equals, I don't know. The first thing we need to do is figure out a polynomial for cosine. Now this does not say that the center is 0.2. It doesn't tell you where to center your polynomial. You want to center it at some place convenient that's close to 0.2. And that most convenient place is x equals 0. So we're going to center a polynomial at x equals 0, which is convenient because now we have a Maclaurin polynomial. Thank you.
If we get something like this on the FRQ, should we say that we're centering the polynomial at 0?
Yeah. So we're centering at 0, and that means our cosine polynomial, cosine x, is 1 minus x squared over 2 factorial, and then we stop here. Stop here because we want second order. Second order means second power. Second power. Order equals power.
So for something like cosine, they would never ask for the third order.
If they ask for the third order, then you would have to go as high as you can get without surpassing the third power. So in other words, you're not only looking at the second order, you're also looking at the third order polynomial. Okay? That's a really good point. This polynomial here is not only the second ordered polynomial for cosine, this is also the third order polynomial for cosine. Because the biggest power is, or possible, is 2. Okay, so let's plug in our stuff here. Cosine 0.2 is approximately equal to 1 minus 1/2 times, now 0.2 is equal to 1/5. So 1/5 squared. 25 times 2 is 50. This is 1/50th, so that's 49 over 50. That's it. Use fractions. They're easier to exponentiate, or they're easier to find powers.
What if I don't know that 0.2 is 1? I don't know how.
Well, it's 2 over 10.
What?
2.2 is 2 over 5, 2 over 10.
Oh, you're right, okay.
Is it okay to do decimals if it's something as simple as 0.2?
Yeah.
What would you do if the center wasn't 0, but it was like 1 and 2?
You would have to reconstruct, you'd have to construct a whole polynomial, which would make this a much more difficult problem. It's possible, but it's unlikely that you'd have to do full constructions. What else are we saying about this? I said use fractions here. Because these are usually easier to compute. Or it should be easier to compute fractions than it is to compute decimals, especially at the accuracy level that we need. And that brings us to 10. So we want f of x is equal to e to the x. We want to approximate f of 0.4. So where do you propose we center our polynomial? Good. Let's let center be 0. That's pretty much going to be your choice, actually. Let the center be equal to 0. That means f of x can be approximated by 1 plus x plus 1/2 x squared plus 1/6 x cubed, and we stop here. Bye-bye. Have a good day. That is the third order, so just stop there. And now we're going to use fractions. So f of 0.4 is f of 2/5. And I hope you remember that. 1 plus 2/5 plus 1/2 of 4 over 25 plus 1/6 of 8 over 125. Might be easier if we, how do you call simplify? So this is 2 over 25. This is 4 over 3 times that is 375. Okay, so common denominator is clearly 375. So first one's 375 over 375. Let's see. 5 into 375 is 75? No. 5 into 35 is 7, right? 75. So 150 over 375. 25 into 375, that's 4 times 3, which is 12. 12 plus 3 is 15. 2 times 15 is 30. Any questions on that quick mental arithmetic? I mean, I'm sure you can get there, but okay. F of 2/5 is approximately equal to 375, 475, 425, 525, 555, 559. You can add slowly if you like. This should be as much as you're ever going to need to go. You're probably not going to have to add 4 terms together. Usually 3 terms or less. Right?
For both of these, you make the center equal to 0.
Yeah. 11. Maclaurin series for cosine of negative 2x. Now that seems like an insult after what we've just done, right? Don't waste my time with this one.
Just don't put stuff like that in the text. It's an insult. You don't need it.
Actually, yeah, you probably want to waste your time with this one. This is nice and easy. Okay, so cosine u, cosu, is 1 plus x squared over 2 factorial, pardon me, minus plus,
What if it was using u's or x's?
yeah, those would be u's. Because we're going to substitute. 4 terms? u to the negative 1 to the n, u to the 2n over 2n factorial. If you don't have that memorized, I feel really sorry for you now. Not that sorry, but, you know, a little sorry. Just a little. Okay, cosine of 2x, negative 2x. Yeah, negative 2x. You know, at this point, you could be really smart and say, cosine's an even function. So that's the same thing as cosine of positive 2x. You could be that smart. It's possible. I mean, cosine is an even function. Or not. Well, that's great. We're supposed to write this in sigma notation, right? Yeah. Okay, so actually all we need is the the general term. Negative 1 to the n. And we'll talk about this numerator in 1 second. I'm just going to put it in there for now. Now, about this, do we notice that we have a negative number to an even power? 2n is always going to be an even number. So negative 2x is always going to be positive. So actually, that negative is unnecessary. So again, negative number to an even power is always positive. So that negative makes no difference at all. It's just wasted space. Well, in the scope of a multiple choice question, you would have to be able to recognize it.
In an FRQ, if we leave it, is it wrong?
In an FRQ, it wouldn't be wrong. Yeah.
In what instances would a sigma notation happen if n not equal to 0?
If the series came from a derivative and the first term was lost due to differentiation, you would start at 1.
And then that, instead of f of x would be f prime of x, would it be sigma?
Well, you know, depending on how you define things. And I think that's it. Yeah.
When would you want just to put the about equal signs versus just the regular?
Yeah, if you write the general term, implying that the series goes on forever, it's exactly equal. However, if you don't write the general term, implying that the series stops after, say, 3 terms, then it's approximate. Daisy?
Wait, I'm sorry. When is it approximate?
It's approximate if you're only looking at a certain number of terms. Okay. So, like, for example, number 9 and 10, we were only looking at, I think, 2 terms and 3 terms respectively. That's an approximation.
You have the general term. Good. And also, so for this problem, we didn't really need to hide all the terms. We just needed the general term.
Yeah. Yeah. Hang on 1 second.